In this video, I'm going to show you how to create Lathe Project Number 2's assembly model. To do this, you must first have all of the Lathe Project Number 2 part files modeled completely and ready to go in one single folder. File management is an important thing when dealing with assembly drawings and part drawings. If you don't keep all of your files in one location, the same location that you modeled them in, you might have to go ahead and rename or reassociate the files when you reopen the assembly environment. So remember, if you don't want to have to do this, keep all of your files in one location and do not rename them after creating the assembly. If you do this, don't worry, I'll show you how to fix this in a later video. But let's go ahead now and start modeling. We're going to go to the File, New tab. We're now going to open up an assembly file. Notice the first thing that comes up is the Open file window, allowing you to pick a part out of the window in order to insert as your main base part. Right now I'm going to go ahead and hit Cancel and hit the red X up on the Begin Assembly and talk about the assembly environment a little bit before we start. First, I'm going to move over to the Assembly tab up on the ribbon bar and click on it. The Assembly tab is going to be the main tab we use in the assembly environment for this class. We're going to mainly use Insert Component to bring in existing part files into our assembly. We're going to use Move Component to move the component around and show you how the different relationships constrain the degrees of freedom of a part. Then we're going to go ahead and do an Exploded View in order to virtually explode the parts to show how the assembly gets put together. Now, looking on the left on the file tree over here, you'll see you've got mates and you've got the planes, just like in the part environment. The mates are a new item actually. A mate is actually how we go ahead and relate different parts together in order to assemble them. Remember, every part has 6 degrees of freedom. It has roll, pitch, and yaw, so rotations about the X, Y, and Z axes. Then it's got linear motions in the X, Y, and Z axes. So 6 degrees of freedom, 3 linear and 3 rotational. So we have to go ahead and constrain a part's degrees of freedom with respect to other features on other parts in order to assemble an assembly in the assembly environment. Might have sounded confusing right there, and it is until we actually do it. So let's try this out. The first step you're going to do is Insert Components. What that does is it opens up a file window and allows you to pick your main base part. So I've saved all of our project files in one file folder. Notice I've got the 3 standard parts we used to design off of from McMaster-Carr with their part numbers. And I've got the one part we designed, or you designed using the allowance and clearance calculations and figured out the specific part sizes and tolerances for the shaft to fit with these 3 standard parts. So our main part we're going to bring in at first is our shaft that we designed. We'll go ahead and click on the shaft and press Open. At this point, it allows me to orient my part. If you look at the window down in the bottom left corner, it's 90 degrees. I can rotate it around the X, Y, or Z axes in order to orient my part properly when I first place it in the assembly environment. For example, if I wanted to rotate it around the Z, I can bring it vertically like that. If I wanted it to go backwards, I can bring it like that. But I'm going to go ahead and leave it in this orientation like you see in the assembly drawings presented in the lab manual. So when I'm happy, I simply click my mouse button and it fully positions my first part. Now let's look at something real quick. You'll notice that there's a little F on the first base part we bring in. What that means is this part has been fixed. All 6 degrees of freedom have been fully positioned when we brought in this base part. Now if you wanted to relate the base part to maybe a plane or an axis or maybe the origin, you could do so by right-clicking, and you could float the part. Now notice our base part now has a negative sign here. We want to go ahead and now mate our base part, we can make coincident using the file tree up here. We can open up the origin in our original part and make it coincident with the origin in the assembly environment, and hit check mark and check mark. What that did was it created one mate, and it made the origin in the lathe project part model coincident with the origin in the assembly model. Now notice that one relationship didn't constrain all 6 degrees of freedom. However, it positioned my first base part in a location in the assembly environment where I'd like to present it. Therefore, I could right-click on the part and fix it. Now, I'm going to move up to the top window up here and hit Zoom to fit. So all I did there was I brought in my base part, or my main part, using the Insert Components. I right-clicked on it and I floated it, and I created a mate in order to orient it exactly where I wanted it in my assembly environment. At this point, I have a fixed base part where all 6 degrees of freedom are fully located or fixed. Now I'm ready to start assembling. However, I think a good thing to do would be to save often. Therefore, I'm going to go File, Save As, Giorgio Assembly Lathe number 2. Now remember, you don't want to change your project file names after creating the documents, or else you're going to have to go back and reassociate the file names in the actual assembly environment or even the drawing environment if you do so. So therefore, try to name your files appropriately when you're first saving the file. Notice I also saved it in the same file folder my part files were located in. When I hit save, it saves my document and I'm ready for the next step. Now we're ready to start inserting the other parts. You should approach the assembly environment like you're assembling the part from scratch. So the first thing we do is grab the shaft. Next, we grab the bushing that goes on this diameter. Therefore, when we hit Insert Component, we can go ahead and pick the nylon unthreaded spacer. Press Open. What this does is it orients the spacer in the same orientation it was drawn in the part environment. But looking at the spacer, we know we want to rotate around the y-axis in order to orient it correctly. We don't have to do this at this point. We could use the relationships or the mates in order to basically change the geometry's orientation, or you can do it when you first insert it real quick in order to make your relationships or your mates easier to apply. Now, notice also when I brought in the unthreaded spacer on the left, you'll see there's a negative sign. Not all 6 degrees of freedom are fully constrained. In fact, nothing's fully constrained at this point, because I could simply go up to Rotate Component and I can rotate the spacer off plane. Or I can Move Component and move it linearly around the screen. Notice the Move Component and Rotate Component are used heavily when assembling parts in order to move them into position or maybe rotate it into place so you can access different features in order to create mates with the different features. So now let's go ahead and create a mate. The first mate I want to do when I hit mate is I want to go ahead and make a concentric mate. Because if you think about it, when I put this bushing on the shaft, I would like to line up the holes with the shaft right here. So what I'm going to do is I'm going to select concentric, I'm going to select on the whole surface, and then that surface. Now, I could flip my mate alignment, however, that really doesn't make a difference on this part right here. So, in this case, either way will work. When I hit check mark, I have applied one mate between this hole and then that protrusion, and this constrained 4 degrees of freedom. If you think about it now, let me show you that. When I go to Move Component, because the axes are concentric, I can only move out linearly. I've lost the translation up and down and left and right. with the axis alignment, constraining 2 degrees of freedom. The axis alignment also doesn't allow me to rotate on this plane, and then in this plane. I can really only rotate the cylinder. You really can't see it rotate right here. However, it is, if you zoom in, you can see it actually rotates slightly. So this part needs one more relationship in order to fully position it, because actually it doesn't have all 6 degrees of freedom constrained in the design. One of the design constraints and criteria was to have a clearance fit with the shaft. Therefore, the bushing will always rotate on the shaft, having 1 degree of freedom unconstrained. So in order to fully position this shaft and the bushing, we're going to go ahead and just click on Mate. We're going to rotate to the back side, and we're going to click on this back face, and we're going to make that coincident with that back face. Check mark. What that did was it went ahead and made that face and the back face of the shaft, where they contact, coincident or locked together. I'm going to go ahead and hit the Zoom to Fit button and hit check mark to in the mate selection, and now rotate around. So this part has been fully positioned in the fact that it still rotates, but not all 6 degrees of freedom are constrained. So not all parts will get fully positioned. However, if I want to show you how I can make the negative sign go away by fully positioning this bushing. So we're going to do that, and then we're going to undo it. So notice, when I open up the part over here in the Windows tree, I can see the original planes the part was created with, and I also have the original planes in the assembly environment. I can relate the planes to each other as well using a mate relationship. So when I select on Mate and I select Parallel, I can make the top plane of the assembly environment parallel with the top plane in the bushing's part environment. When I hit check mark and check mark, when I go back to my SolidWorks assembly environment and look at the part in the design tree over here, you'll notice the negative sign went away because I've fully constrained all 6 degrees of freedom, and you cannot position that part with respect to the base part any longer. Now, this is not the way we want it in real life. Therefore, I'm going to go back to my mates, click on that mate, and delete it. Now notice the negative sign came back because we still have 1 degree of freedom missing from that part. The 1 degree of freedom is not fully constrained still. And we can still rotate the part. I can see it rotating in the pixels. Now, at this point, realize all your mates are underneath the mate paperclip. So if you click on the triangle, you can go back at any time, right click, and edit the actual mate if you needed to change it up. In fact, if I didn't want to make this one coincident, I wanted to make it a small distance of 5 thou, I could do so. And at this point, when I zoom in, you'll see there's a 5 thou gap in the part right there. So editing mates is as easy as going back, right-clicking, editing the feature, and changing the mate either up here for the entity to mate or down here the mate type. Check mark. Now I'm going to go ahead and press save, and I'm going to bring in my next part. My next part is going to be the washer. So when I hit insert component, I go over to the stainless steel fender washer. I press open. Now I'm just going to orient the part using the Z-axis to flip up the washer. I'm going to place it close to where I want to start mating the washer. And then I'm going to go ahead and click on the mate button. Remember, round parts like to get assembled through their centerline axes. So a concentric relationship will go ahead and make sure that this circle is concentric with that circle. Check mark. Now remember, that constrained 4 degrees of freedom, and in this design, the washer's back face will actually butt up with the back shoulder right here on the part when the nut crushes down on it. So to get that performed, we're going to select the coincident relationship, click on this back edge, zoom out, hold my middle mouse button down, the roller, to rotate around, zoom in, and click on the washer's face. Now if you notice, we have a slight distance between those two. We can show you how to actually set up a relationship to where it just goes back and forth and limits that in a few moments. So moving back over here, we're going to go ahead, hit check mark on the mate relationship there. Now when I go back to the coincident relationship, I'm going to right click, I'm going to edit feature. Looking at where the washer is, this part actually can move back and forth slightly. So we want to set up a relationship that's like that. In order to do so, we can go ahead and set up a distance relationship and limit the distance, or we can set up a width mate and put it right in the center. Now, we're going to go ahead. So what we can do is we can actually change this coincident relationship by right-clicking on it, editing it, and changing it to an advanced mate, such as limit the distance. With this one, I'm able to go ahead and allow it to sit at a certain distance. Then I could limit the 40 thou. These numbers aren't going to be the same for your design, and 0. So the closest those two surfaces can be are 0. The farthest apart are 40 thou, and I'm going to set them up at 20 thou. When I select that, notice I go to move component, and I can now slide it back and forth like you'd see in the assembly. So this part has a clearance fit around the shaft with the inside diameter of the bushing, so it can rotate, and then its distance is limited by the washer and the shoulder on the shaft. Just one way to go ahead and set up a different style relationship. Remember, you can set up the assembly environment and model your assembly to perform exactly like it would in the real world, hence the paperless design. So at this point, we're ready to go ahead and put on the nut. The nut can be inserted by hitting the Insert Components button, selecting the grade 5 steel hex nut part model, selecting Open, and I'm going to rotate it around the Y in order to line it up. Now notice the nut, when I open up the nut's part environment and look at the different features, there has been a sketch created right here. You'll see that sketch is a circle. What that allows me to do is it allows me to concentrically relate the nut with the actual workpiece, or the part, the main part. So what I'm going to do is I'm going to hit Mate. I'm going to select on the sketch, and I'm going to make that concentric to the shaft, and hit check mark. Now, notice we want to go ahead and place the nut on the shaft here. In order to do that, we can actually make a screw thread relationship. So we're going to go ahead and create a screw thread relationship with the nut here and the shaft. In order to do so, you have to have an axis line drawn on the shaft, and then the circle line on the actual, or the circle sketch on the actual nut. So when I hit Mate, the screw thread mate is a mechanical mate. If we go down here and we pick screw, revolutions per inch is your threads per inch, so there's going to be 11. Now we have to pick the axis that it's going to, the nut will revolve around, then the circle that it's going to go ahead and rotate about. So to do this, when I hit check mark, you'll notice as you rotate the thread, it screws on. But what happens is it goes through the actual washer. So we have to go ahead and limit this somehow. Let me unscrew this. So to do that, we're going to go ahead and limit the distance. So we're going to go ahead and click on Mate. We are going to click on the Advanced Mates. We're going to pick a distance limiting mate. We're going to set it at 0 when it's all assembled. We're going to say that it can come off 3 inches and it can go down to 0 inches. And we're talking this face and this face. Check mark. So at this point, when I rotate it around, you'll see I can unscrew it and then screw it back on. And in order to move these models, I'm just holding my mouse button down, and notice it stops. I hold my mouse button down and drag the parts. So you'll see we can fully thread the part on. Now at this point, we want to clean up our model a little bit. You can notice that we see the axis of revolution still, so I can right click and I can hide it. And I can right click on this sketch and I can hide it. Notice there's one other sketch in here. I can see the construction line. I can right click and hide. Now when I hit space bar and isometric, I have a fully assembled lathe project number 2 design project. So I'm going to go ahead and hit save. Now we have to go ahead and create an exploded view configuration if we want to show the part in an exploded view in the drawing environment. So we do this in the same file that we just created the assembly in. In fact, in order to create an exploded view, we have to go over here to this configurations tab and look at our different view configurations. At the moment, we only have a default view, the assembled view. In fact, I can right click on it, I can go to the properties, and I could call it assembled view and hit check mark. Now if I want to create another configuration, an exploded view configuration, I can do so by going up here to the top and clicking on exploded view. What that's going to do is that it's going to allow me to pull apart my part and show how all the different individual parts fit together in the assembly. You do this step by step. So you simply can click on a part and then you figure out if you want to rotate it or linearly drag it. So we're going to take this nut and we're going to drag it outwards. Now that created one explode step. I can go ahead and explode multiple parts by clicking on multiple parts, then dragging them outwards. Notice I created a second explode step. At this point, I'm going to go ahead and drag away the washer a little bit more. Check mark. And this fully shows, when I hit spacebar, isometric, my part exploded. So I can see the 4 different parts and how they line up in the assembly. When I'm happy with my exploded view, I can hit the green check mark. If I wanted to and go back and change the explode steps, I could click on them and I could actually go back and change the distance in that step. You could also rotate them off axis if needed. We'll do that in a different video. At this point, I'm going to hit check mark. What that does is it creates an exploded view in your assembled view configuration. So notice I can right click on that exploded view and I can click on animate collapse. What that does is it'll put it together exactly the way you exploded it. Or I could right click and animate explode. This is a real nice way for you to create a simple video and show it in your design presentations. If you wanted to do that, notice up at the top of the screen is you hit Save Animation and put this video directly in your PowerPoint. But for now, I'm going to right click and Animate Collapse. So once you have an exploded view configuration down here, you're done with this step of the assembly environment. You can create as many exploded view configurations as you would like. We only need one for this assignment. So I'm going to go ahead now and press Save, and we'll go ahead and stop this video at this point and go ahead and watch the second video on how to create the assembly drawing for the next portion. See you in that video.